Okay, good afternoon, or actually good evening by now. And welcome to the new form of our recitation. So, not entirely sure what to tell you, but here we are. This is it. If you don't have a microphone and you want to participate, then you can, if you want to participate vocally, audio, or talk, that is, then you can use that phone number and enter that PIN. Hopefully that's right. Those of you who have microphone can talk using your microphone, but not right now because I have muted all of your microphones. Because it's just all the background noise, things like when you click your mouse, when you're walking your mouse or just clicking on it, just make a lot of noise when all of you are combined. And so there's that. You may, during this portion of the class, ask questions over in the public chat room there on the left. Go ahead and just type your courses in. Here is, if I got the link right this time, you have an updated announcement for this meeting, and the workshop that we're going to work on is there at that link, or you can just go to Files and Recitations and you'll find it there. Also down here in the bottom is you should be able to download this presentation. Down there in the bottom left corner, you can give that a shot and do that as well. But I will now start the workshop, the recitation, I mean. So some of this part here is a repeat. Your recitations will be held at the same time as typical, as you all no doubt figured out. The recitation will follow this this format. We're going to have 5 to 10 minute lecture on a topic, as always, except that instead of doing, I'll talk about the topic instead of going over the quiz or the previous workshop, or maybe I'll talk about the quiz and the previous workshop as well a little bit. But the quiz, of course, will still be, not of course, because the quizzes will be different. I'll get back to that. You'll have access to the quiz answers somehow. Then we're going to go into breakout rooms for pretty much the remainder of the recitation, and I will talk to you more about the breakout rooms in a second. But first, I want to make clear the breakout room is going to open in another tab. This here that we're in now, this is the main conference room, and it's going to remain open in this tab. Do not close this tab because you'll be coming back to this. Do not close this tab, and you'll also need it if you want to get the attention of the LA or myself, Rajuda, to be exact. Okay. After the breakouts, you will be given a quiz. The quiz is likely to be delivered in Sapling. It is a timed quiz. You'll have about 20 minutes to complete it. However, you do not have to complete it immediately after the recitation, right? During the for regular in-person recitations, we gave you the quiz right at the end, but now it'll be online. You'll have some time, probably 12 to 24 hours to complete it. I was told that Professor Ullman was going to give you more than the usual time this first week, but I was told in the last recitation that he told you in lecture that there's not even going to be a quiz this week, so there may or may not be a quiz this week, and you don't have to complete it immediately after the recitation anyway. And write-ups will not change. They will be assigned the same way as before. They won't change. Okay. And before I continue, I want to talk about the breakout rooms, but you're all muted, except I believe the LA, Rajuda should not be, Rajuda, if you could try to speak briefly, just to say something, and so I know that I can hear you.
Hello.
Hi, Rajuda, good, okay. Okay, so the breakout rooms are going to be like basically working in groups. You're going to work in groups on the workshop problems. Again, the workshop problems are available here, or just go to file. I know you can't click on that link, unfortunately, but just go to Files in Canvas. The breakout rooms are not recorded. This is being recorded right now, so you can refer to it later, but the breakout rooms, be aware, are not recorded, so make sure you keep track of what you're doing, take notes and all that, okay? Unlike other professors, I've decided to let you try and choose which room you can go into, and then you can also move around rooms. Well, I mean, I think you have to stay in the same room for the whole time, but other students are telling me that they've figured out how to move around to other rooms. So if you, if you can move around, you don't have to do this. You don't have to use the private chat to figure out what room to go to. In the breakout rooms, one of the students will always be the presenter. That student can move the slides back and forth. I will load up the slides in a moment after you start so that you can get to these slides and other things. And then also, whoever the presenter is should, over here on the right side, they should click the bottom right icon so that you can all share the whiteboard space. You can all work on the whiteboard space at the same time, just like you were doing before this class started. No, only Andrew, only I can switch the slides right now. I'm the presenter. I'm currently the presenter. Okay. So just some quick things that you'll be able to do in there. Right here is turning on multi-user whiteboard. Please turn it on and leave it on. I think will be best for you. I recommend once you do that, each of you choose a different color to write in. Okay. Down here is how you can take presenter. Oh, good. I circled the red by circling in red, huh? Here we go. How about blue? Right here, the big blue, the blue plus is how you can take presenter. You can take the presenter mode, and once you have the presenter, then you can switch the slides and do other things. Once you are the presenter, you will be able to upload a presentation. Most of you probably won't want to do that, but if you have something you want to show your group mates, you can do that. You can upload it that way. But I'm going to go around and upload this presentation into each of the rooms after we break out anyway. Okay. Here you can mute your microphone. I don't know if you can see that in blue that I'm writing right here. And I recommend you do mute yourself except for when you actually want to talk. When you want to talk, you can click on the blue and reactivate your microphone, and you can start talking instantly. It connects right away, as I've been doing. So I recommend you want to keep it muted until you actually want to talk. And then you also can turn off the audio in case you don't want to hear I don't know why you'd want to turn that off, but there it is. And also over here is the camera. You can use the camera in the breakout rooms. And this last icon here is the share your desktop. I think you are not able to do that. At least I wasn't able to do that, and I'm the moderator. So there you go. In the breakout rooms, those breakout rooms are like are substituting for the groups, working in groups before. So you'll work on the workshop problems, which you should have access to already, or they will also be on these slides here. You can use your camera, but beware that it takes up room on the space. And then you can also talk to each other using your microphone. I suggest you do that, but be careful not to talk on top of each other. You can write on the shared whiteboard. And also on the left side, notice the link above your usernames called shared notes. You may want to use shared notes. You can find that useful also. The learning assistant and myself will cycle through the rooms and help you out. At first, I'm going to come around through the rooms and just make sure everything is working properly. And then I'll come back and help you all with math. Judah will probably start right away helping you with math. And the way to request help, if you want to ask either of us for help, is to go back to the main conference room. That's going to be this tab, the one I told you not to close, and ask for help in your room. You don't have to use this exact text. I don't care if you use this exact text, but you do need to tell us what room number you're in when you ask for help. So say in room something or other. Okay. Any questions on that, the basics there, how we're going to get along and try to make this work? Please bear in mind, this is new to everybody. If you have questions, you can't use your microphone right now. You can type them in the public chat. If you want to get the question out quick or interrupt us quickly, just use an exclamation mark. Type an exclamation mark. Hey, I want your attention, like that. Okay. And I don't see any questions. That was just administrative stuff anyway. So today's topics that we'll talk about are related rates and linearization. But related rates, I'm actually not going to spend a lot of time on because that is already really past. That is past work. The only reason Professor Ullman put related rates problems on this workshop is because we didn't assign anything last workshop, so you may not have had enough practice. So what I will do is remind you a little bit about related rates, what they are and what they represent. And the object of related rates is that you may have a situation where you have multiple variables, two or more variables, they could be called X and Y, and they are changing relative to a third variable, usually T for time. Okay, so for instance, if a car is moving 30 miles an hour, then its distance or the car's position is changing over time. It's changing relative to time. And so if you have some variable which you've named X, then how fast it's changing should be called dx dt. It's changing at dx dt speed. The rate at which y is changing is dy dt. Okay. Note that dx dt, the derivative of x, is not equal to 1. Derivative of x in related rates is not equal to 1. dx dt represents how fast x is changing in time. How fast x is changing in time. Likewise, dy dt represents how fast y is changing relative to time. And just to relate this to some of your previous work, note that dy dx represents how fast y is changing relative to x. Whoops, why did that just go away? Of course, how fast y is changing relative to x that's the slope, right? The slope is how fast y changes for each unit of x, as you guys knew. So related rates is really the same thing as before. I'm going to skip this slide. That wasn't very useful. Okay. Any questions on the idea there? Okay. So now I'm going to share my screen then and talk about linearization. I'm kind of rushing. I know I'm kind of rushing because, there was a lot to say with both the, having to talk about how we're going to do recitations from now on and this material. Okay. So I'm now sharing my screen. I believe you all should be able to see it. Just beware at this point that I cannot see the conference screen, so I cannot see when you guys are trying to talk to me through the public chat or anything like that. If there's anything important, maybe Rajuda, if there's any questions in the public chat, Rajuda maybe can try to answer it. Or since Rajuda can speak to me out loud, you can get my attention, Rajuda, by just letting me know that there's a question that needs addressing in the main room. Okay.
Yep, sure.
Okay, thank you. So here is the story of linearization. First of all, what we have here in black here, this is the function f of x. It doesn't matter what the function is. Don't look at the fact that it's the square root of x. Ignore this part over here in the top left. This is our function, f of x. Okay. There's the function f of x. And I'm going to add some notes now in the top left of the screen here. Right? The function is f of x. Okay. And the tangent, the linearization, it turns out, is just the tangent line. Linearization is just a fancy name for the tangent line. So we're going to create the tangent line here at a comma f of a. This is the tangent point it should be flashing on and off for you guys, hopefully, to highlight. I never know if you can see my cursor or not. That is the tangent point. It's at the point where x equals a, and the y value, the tangent point's y coordinate is f of a. Okay. So in the top left there, a comma f of a is a tangent point. The tangent point is a known point, or it's an easy to calculate point. And I want to get rid of this at the end there because it's getting in the way. And obviously, the tangent point is on both the curve and on the tangent line. Okay. The tangent line, where's my next comment? The tangent line at the tangent point is in blue. The line in blue is the tangent line. It has this equation here, L of x being f of a plus f prime of a times x minus a. Now that is not new. That's fancy notation, but it's actually, that is just the tangent line. Instead of saying y, we renamed y to L of x because we want to use it as a function. It's just L of x here. I don't know if you can see my cursor where I'm pointing. So y is L of x there. And then y minus the y coordinate. Well, the y coordinate is f of a. Right? So the tangent line is y minus the y coordinate. And that equals the slope. But the slope m, that's the derivative at the tangent point, right? That's almost the point of calculus 1, is that the slope is the derivative at the tangent point. So f prime of a, and then x minus a. This is just the tangent line equation where we renamed y to be L of x. That's all. And here's the important thing to know about the tangent line. Points on the tangent line that are close to a, so long as x here, look on the bottom on the x-axis, I have the value of x. As long as that's close to a, then the point f of x, which we want to know, is close to L of x. L of x being the y coordinate on the tangent line. Good. So this point here, this point here, the value f of x is close to the value of L of x. L of x approximates f of x so long, but only when x is close to a. Right? Let me illustrate what I mean here. When x is close to a, L of x is close to f of x. But watch what happens when I stretch x far from a. When x gets far from a, L of x gets farther and farther from f of x. Okay? So points on the tangent line, the y value on the tangent line is close to the y value on the function. Okay, so and I don't know why this label here is going off the screen, but to be clear here, now look below the point x comma f of x. We want to know the value of f of x. That's what we want to know. Or we want to know the value of the point. We want to know the value of the function f at the point x. We want to know f of x. The point that we know is f of a. We know that point because that's the tangent point that was either given to us or it's easy to calculate. But we want to know f of x. F of x is hard to find. However, L of x is easy to find because that's on the tangent line. That's on a line, and those points are easy to calculate. We can find L of x. And L of x is close to f of x. Therefore, L of x, we use L of x to approximate the value of f of x. Again, we can only do that so long as x is close to a. That's the main idea of differentials. Any questions there? I'm back looking at the conference. Do you have any questions on the idea there? Of course, the practice, you have to go in and practice it and learn how to do it. I don't have time to do a problem, but okay. I don't see any questions coming in. So I want to add one more thing then about linearization, and my notes now are going to be at the bottom of the screen here. Linearization and differentials is the same thing.
There's a small question.
There's a question.
So Andrew is asking that, are we supposed to know when the values are close?
Well, not yet. The short answer is in a future semester, yes, but not now. In a future semester, that gets defined using, well, I think it's that we start to define that in Calculus 2 when we talk about error bounds and all that. Okay. I'm going to go on. I can't get any feedback, so I'm going to assume that was a good enough answer. Good question, incidentally, by the way. Okay. So the last thing I want to say about this is that differentials is the same thing as linearization. Note that differentials is the same thing as linearization, but with a different notation. Whoops. The biggest difference is that x minus a, look up here in the top right corner at the equation for the linearization again. X minus a is replaced with the symbol delta x. It's a change in x. Okay. And differentials are really mostly useful when all you want to know is the change in value or the change in y. It might be useful when you don't know f of a, or if you do, you have an expression for f of a, but you don't have a value for f of a. Anytime you're asked to use linearization, you can use differentials, and anytime you're asked to use differentials on a test or quiz, you can use linearization. They are the same thing. They're exactly the same thing, just with different notation. So you can do whichever you like. Now, we doing any questions there? Any questions? Any other questions? Okay. I am now going to break us up into breakout rooms. I will, after I do that, I'm going to come around and load up this presentation for you so that you can, not this presentation, but the presentation back in the main room so that you can page around it. Pardon me. You guys will be able to move around it and choose which problem you want to work on. And let me just first see, when does this class end? This class ends at 10:30, and it is now 9:36, so there's about 50 minutes left. So let's make this 45 minutes, and you will be able to choose your room. And I am going to break out right now. We'll just see, no questions coming in. Okay.
You are currently the only person in this conference.